Greetings all. So in the last lecture we derived the temperature profile for the case of cylinder in which heat is generating at the uniform rate volumetrically, and we found that temperature profile comes out to be as parabolic profile. But it turns out that we know surface temperature. We don't know surface temperature. We only know the ambient outside temperature, heat transfer coefficient, and the value at which heat is generating inside the cylinder volumetrically, right? We know only these parameters, but we don't know what is T surface. So we have to convert this Ts in terms of knowns, right? So we have to convert this Ts in terms of knowns, and knowns are nothing but our heat transfer coefficient, ambient temperature, and ambient fluid temperature, because outside fluid is there, alright, which is cooling the hot cylinder. Okay, so we can approach that by applying the energy balance, considering the control volume over the whole cylinder. Alright, so writing the energy balance as heat coming in minus heat going out, plus the whatever heat that is generating inside the cylinder overall, equals to the heat stored inside the cylinder as the sensible energy, or means it's internal energy, right? But it is steady state, so there will not be store of any energy. And also, since the maximum temperature, we can see here that maximum temperature is inside the cylinder, so it means that the heat cannot come in, so heat will be only going out of the cylinder. Alright, so but if the outside fluid is having at higher temperature and inside there is no heat generation, then heat can come in. Alright, so in that case we have to consider that heat is not going out, heat is coming in. Okay, so I hope this is clear. So from this we can see that heat will be going out of this cylinder. Alright, so only this term and this term will be remaining. So heat is generating at this rate, the Q generation, which is nothing but the watt per meter cube times the volume of the cylinder, equals to the heat transfer coefficient times the surface area of the cylinder, right? Surface area of the cylinder, this cylinder, alright, times the surface temperature minus ambient fluid temperature. Surface temperature is this. We are assuming that at every surface there is constant surface temperature which is maintained by the fluid outside. Alright, so by simplifying it, we can get the surface temperature in terms of ambient fluid temperature, heat generation rate, and the H. So we have fulfilled our promise that we will be converting the surface temperature into known terms. Alright, so if we know this TS value, we can then plug in this temperature profile and we can find temperature at any radius r. Alright, so this is all about the heat generation case, and this is also the end of the basic heat transfer conduction. So in the next lecture we will start our unsteady heat transfer and fins. Okay, and as an exercise you can try this problem that for the case, for our fourth case, when there is heat is generating inside the sphere. Alright, surface is maintained at a constant temperature Ts by the ambient fluid, which has characteristics of heat transfer coefficient and free stream temperature T infinity. Alright, and what you have to do in the same way as we did for cylinder. Okay, we have to find the temperature profile inside the cylinder. So as a hint, I'm saying that start with governing equation for the sphere, and to find the surface temperature Ts, proceed in the similar way as we proceeded for the cylinder, like energy balance, right? So with these two things you can derive the temperature profile for the case of sphere for any radius r. And also one more case you can try. For the case of, let's suppose this is some chip in the electronic component, and the chip thickness is very small and length is very large as compared to its thickness, so that we can assume it as a plane wall, and its left side surface is insulated, and the outside surface, suppose by the fan the air is blowing, as in case of our, like, let's say this is CPU chip, right, and air is blowing by this fan inside our laptop to cool this chip, CPU chip. Okay, so we have to find the temperature profile inside this chip. All right, so these two cases you can try by yourself. Okay, and I'm saying that this is the origin x and this is the length L of the, and heat transfer is one dimensional. Heat transfer will be in this direction. All right, and heat is generating inside it at the uniform rate. In this also uniform rate, steady state. So with this is the end of steady state heat transfer. Okay, so in the next class we will start unsteady state heat transfer as well as fins. Thank you.